Alright, how many of you guys know how to graph on an XY? Awesome, this is great. Okay, so my name is Clay, and I go to USF for mechanical engineering. And we're going to have to do a project in a class called machine design, where we have to teach engineering or science principles to kids K through 12. And lucky for you, this is the presentation. So, we're going to do something called projectile motion. And projectile motion happens whenever something is launched through the air. You get someone shot out of a cannon, the person is the projectile, and they go flying through the air. So you have something that gets launched, and it goes up, and it comes back down, and it hits the ground. Now, what science has done for us in physics is they have given us equations to where we can find the height, we can find the distance, we can find the time it takes to reach there, and we can know all that just from a little bit of data that we have that we can measure. And so one thing that you need to understand, and the goal of this is just to make you aware of these things and not necessarily to try to teach you, but hopefully just to kind of spur you on and give you some curiosity about it. Whenever you have something moving in an X and Y, you can do this. You go over and up, over and up, over and up. This one will be X, 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 and then Y, Y, Y. Just like when you're graphing and you have, you go 3 over and then 2 up, that's your X and your Y. You're sideways and then you're up. So whenever something is launching like this, it has over and up, over and up, over and up, all the way through. That's how we measure it. So just kind of expand your mind. Whenever something is moving, it goes over and up, and that's how we measure it. So I got some sheets to pass out. These, if you fill these out right, you can get extra credit. Mr. Evans has agreed to let me have, or give you guys some extra credit. So we're going to go outside, and as a projectile, we're going to launch water balloons. And they're going to hit the ground, and then we're going to take some measurements, and then you guys, we're going to come back here, we're going to do a little bit of equations, and then we're going to find out a lot of things from these equations. You guys are fast.
Can I be the target?
Sure, you can be the target. Alright, you guys remember your timing? Okay, just practice it. And then you'll just practice measuring.
Is there a chance of it like falling down?
Oh, it looks like this is so cool.
Alright, you guys, just practice. We got our timers, we're gonna practice, and then Elizabeth's just gonna help us measure. Alright, you guys ready? So just look at it and see how it's gonna go, because then we're gonna have to take some measurements. Alright, back up.
Oh, should I be standing over there?
Timer, did you time?
Yeah, really.
Alright, we'll do it here. We'll do it again.
I wasn't ready.
Alright.
Watch.
We'll count to 3, okay?
Alright.
Alright.
When I measure, do you want me to stand over here and just kind of guess what I
No,
measure?
you're gonna take this thing, and you're gonna walk to where the balloon landed. So if you want to start walking. Okay, wait, come hold this for a second. Just hold it. Alright, Elizabeth, step to the side. Alright, you ready?
Yeah.
1, 2, 3. Alright, stand right where it landed.
You got it accurately this time.
Alright, what'd you get? That's good. What'd you get?
1.7 seconds. 1.4.
Yours is too high.
I'd go with the first one. Oh.
Do what?
I'd go with the first one.
Okay. Alright, step to the side.
That's like, no. Get me back up. It's over. I got 1.79 seconds. I got 0.41.
That's good. Alright, don't record any of that. You don't have to record it. We'll do that later.
Hey. I'll help you. Alright.
Alright. So, we increase the angle. We increase the angle of launch. So what should happen? We're at 45 degrees. What should happen? It should go farther than where you're standing. Let's see if it does. Can you hear me good? Ready? 1, 2, 3. All right, somebody give me some numbers. What was the first box?
73.25.
73 and a half? All right, second box?
78.
Third one?
75.
75. Okay, what was this one?
2.33 and 0.97.
This one?
2.33 and 0.97.
And what was the third one?
2.15.
2 point
1.5.
and,
0.8.
No, it wasn't.
all right, what was this one?
22.
22.
I put 30.
31.
Oh, that's the, okay, yeah, you guys guessed that one, all right. It'll be individual, okay. So we'll leave these out. All right, so I guess we're gonna take the average. We'll take the average of these. Let's say this one's like 2.2 seconds, and this one maybe 0.9. We'll actually see if it's way off. That's the thing about these equations, is they'll give us exact answers. And so we'll see how far off they actually were. All right, and then the top, we're going to use number 75, looks good. All right, 75 feet, seconds, and seconds. How do you put that? Okay. So, on your first question, you have, does a 45 angle make the most x distance? Is that true or false? Yes or no?
Yes.
All right, go ahead and circle yes. And then out on this side, put +1. You get 1 point extra credit for answering it right. Okay, so if 45 is the most amount of x distance, why would you want to shoot it higher or lower? Why?
To add more time.
Add more time? Why would you want to add more time?
Give them
More speed going down.
More speed going down? Very good. What'd you say? Okay. It would be more of a show. Like, that's why we launched at 50 degrees, because I wanted you guys to see the big overarching thing. If you're going to shoot somebody out of a cannon, do you want it to be really fast? No, you want it to be really long and everybody can see it and get their money's worth. What's another reason why you would shoot it higher and have it go higher in the air and then come back down? What about if you had to shoot something over a mountain or over a building? You think the military sometimes can't shoot something over here because there's a mountain in the way or a building? They have to shoot it up higher and have it come down. Why would you want to shoot it shorter and have it go less high in the air?
if you want to move the target, so you need to shoot it faster.
Very good, very good. Any other reasons? What about if you want a surprise attack? Like, you don't want to see it coming, like the moving target. If you want to shoot it, you don't want to see, hey, there's something coming at me, I need to move. You want to be really fast. Okay, so that's a little bit about that one. Number 2, we're going to use the maximum height equation, which is this. You have your distance in the up direction is equal to the speed in your y direction, I mean your up direction, times the time that it took to get there, plus 1/2 of the acceleration due to gravity, and we'll talk about that in a little bit, plus the time squared. I should write that. You guys don't got to write that down. Can everybody see that? Is that too small? Okay. So, let's start filling in some stuff. We got our distance is going to be equal to our speed, and our speed is 33 feet per second. That's something I calculated outside of class. Your speed is 33 feet per second. That's about 22 miles an hour. So we were shooting about 22 miles an hour, which is pretty cool. And then you have multiplied by, you guys know what that means, multiplied?
Yes.
That's very good. Oh, that's really good. I didn't learn that until I was in high school. All right, your time. Our first time was the time it takes to get to the half, which you were measuring, right, Alice? Okay, so we use our first number, not our first number, our average, which is 0.95. So we put that in for our time, 0.95, plus 1/2, and then, which is our 32 feet per second is how much gravity pulls down. It's just a number, you'll learn that later. And then we put in our time again, 0.95 squared. All right, so let me put this in my calculator. Pretty close. I mean, within a couple feet, you can measure that just by using a stopwatch. It's pretty interesting. So that's pretty much all I got on the presentation. Hopefully, you know, it's kind of piqued your interest. Maybe you want to get into these things as you get older. You can work for NASA or airplane companies or anything like that. And if you have any questions, do you have any questions? Nothing? It was pretty cool? Yeah. You guys excited about projectile motion? You want to get hit with it, Jeremy?
Huh? Yeah,
Any
and,
question?
I wanted to ask, where did you get those balloons at?
I had to drive to 3 different stores because they didn't have them. I got them at Walmart. I got a bag I'll give them to you. They're only like $1.
That's not
Oh, that's not it.
Yeah, I'm leaving.
All right, I can't give them to you then. All right, any other questions or anything? All right, I want to thank Mr. Evans. You guys have a cool teacher for letting me come in.
Thank you.
And that's all. Thank you.